So this is a second tutorial on converting fractions and decimals, and we're going to look solely at repeating decimals this time. We've already done a video on converting fractions to decimals and converting decimals to fractions. This one is a little more complex, so I've separated it into a separate screencast. You can take a bit of time to go over it. So let's look at this repeating decimal here, 0.4 repeating. So that means it's 0.44444444. It doesn't terminate. When we were converting normal terminating decimals into a fraction, we looked at where the last number was, and that became our denominator and our divisor. Here, because it doesn't terminate, we don't know where it ends. In fact, it doesn't end. So we've got to find another way of doing it. And we're going to use algebra. We're going to use simultaneous equations, really, to solve it. So we're going to make x equal to 0.4 repeating. And then if I do 10 times both sides of that equation, x becomes 10x, 0.4 moves one place value to the left to give me 4.4 repeating. I've now got identical repeating decimals. And what I can do now is I can subtract this equation, x equals 0.4 repeating, from 10x equals 4.4 repeating, and the terminating decimals will eliminate each other. So that leaves me with 9x equals 4. Now, to get back to find out what the value of 4 is, to solve that equation, I'm going to divide both sides by 9. X equals 4 over 9. Nice and straightforward. Here's one where we've got two decimals that repeat. So this is 0.343434, again doesn't terminate. Now if I multiplied this by 10 as I did over here, I'd end up with 3.434334. I won't have identical repeating decimals, so I wouldn't be able to eliminate them. So what I'm going to do instead is I'm going to multiply it by 100. That means it moves over two place values. I'm left with 34.34 recurring. So now you can see I've got this equation with a repeating decimal and this equation with a repeating decimal. I can now subtract them again from each other, and the repeating 34 will be eliminated. So 100x becomes 99x, the 34 repeating disappears, and I'm left with 34. Now all I need to do is divide through by 99 this time, and I've got x equals 34 over 99. So let's look at one that's slightly more complex. This will be exceeding expectations for Unit 1. This is a very unusual repeating decimal in that the 1 after the decimal place is not part of the repeating sequence. Only the 27 is. So this number is 0.1272727 doesn't terminate. So I have to put an extra step in. Remember, all the way through I'm trying to formulate two equations that have got identical repeating decimals. So if I multiply it by 10 to start with, I'm going to move that 1 up to here, and I would have 1.27 repeating. They're not identical. I can't subtract yet. I've now got to multiply both sides of this equation by 100 to move it two more place values over. And now you can see 10 times 100 is 1000x. This has moved two more place values over. I've got 127.27 repeating. I've now got two equations with identical repeating decimals. So if I subtract one from the other, 1000x take away 10x is 990x. The repeating decimals are eliminated, but what you must remember is you've still got a 1 here to subtract. So 127 take away 1 is 126. Now I divide through by 990 to leave x equals 126 over 990. That will simplify. Let's leave that. You can do that in your own time.